Okay. Hello everyone, my name is Xupeng from Green University of Electronic Technology. I'm very happy to share my paper with you here. The title of my paper is Enhanced Packet Marker with NT Information for Aspect Sentiment Triplet Instruction. Next, I will introduce our paper in the following 4 parts. First, the background. Aspect sentiment triplet extraction task aims to extract the more structured, informative data from large amounts of review sentence. This data can be used in intelligent recommendation systems. For companies, they can better understand market dynamic and customer needs. And for governments, they can have a more comprehensive understanding of social issue. Here is an example of ASTE. Give a sentence, we need to extract the triplets, which consist of aspect terms, opinion terms, and the sentiment relationship between them. Although extensive research has been conducted on the ASE task, most works use span representations to predict the relationship between spans, but ignore the interrelation between the span pairs. So we introduce a subject-oriented packet strategy to model the interrelation between span pairs. On the other hand, existing research ignores the importance of entity information. One of the biggest challenges in extracting triplets is to correctly extract entity information. This is what we expect, but this situation is common. So we insert typed markers into the sentence to incorporate entity information. In the second part, we will introduce our research contents. Here is overall architecture of our model. Our model consists of entity recognition model and the sentiment classification model. The procedure of triplet extraction is as follows. First, the entity recognition model extracts entity from the input sentence. The entity information includes the entity boundary and entity type. Then the entity information is used to construct a new sentence as the input of the sentiment classification model. Subsequently, we used encoder BERT and graph convolutional networks to get the span pair representations. Finally, the triplets are predicted based on the span pair representations. Before introducing our model, I will first introduce the levitated marker. Levitated marker consists of 2 parts, the begin token and the end token. Moreover, levitated marker share the same position ID as the start and end token of the corresponding span. Here is an example. This is the levitated marker of span grade, and this is the levitated marker of span grade food. And they share the same position ID of the corresponding span. For a detailed introduction of the levitated markers, please refer to the work of Ye. And the next is typed marker. The typed marker consists of front and back 2 parts. Unlike the levitated marker, it doesn't share the position ID, but it is inserted before and after selected entity. That is subject span. In addition, the typed marker also comes with the typed label of the entity. Here is an example of the typed marker. Yes. And next, I will introduce the detail of our model. In entity recognition model, firstly, we arrange all spans in the review sentence, and all candidate spans are split into several groups, each with a size of k. Subsequently, a group of levitated markers are concatenated onto a sentence, generating a chaining instance. Then we get the span representation and get the probability distribution of the entity type. After we get the entity, we select one entity as subject span and insert typed markers around it. The other entities are marked by the levitated markers. And finally, we get a new input sentence. The subject-oriented packet strategy is embodied here. Each input sentence has multiple span pairs with the same subject span. In sentiment classification model, we input the sentence into encoder BERT to get the representations of each token. Next, we use graph convolutional networks to fuse the syntactic information with the token representations. Then concatenating the representations of the subject span and object span to get the span pair representations. Finally, we predict the probability distribution of the sentiment. Next is our model performance. We conduct the experiments on the following data sets. The data sets comprise review sentence from laptop and restaurant to domains. And this is our main result. According to the result, our model outperformed the best baseline by 5 to 9% on F1 score. And to validate the ability of our model in pairing aspect and opinion terms, we conducted experiments on the AOP task, which aims to extract aspect opinion pair from the sentence. The result shows that our model works well on the extracting span pairs. In the experiment of inference speed, it is proved that subject-oriented package strategy can obviously improve the inference speed. And without pack means that we don't use the subject-oriented package strategy. In ablation experiment, we can find that the effect of inserting a marker is most obvious. Moreover, when the relationship between span pair is not considered, the performance decreases, proving the effectiveness of considering the interrelation between span pairs. Finally is the conclusion part. Our contribution is as follows. We propose an enhanced pocket marker with entity information framework. EPMEI can extract a sentiment triplet more comprehensively and effectively by adding additional entity information and considering the interrelation between span pair. Second, we use typed marker to highlight the subject span and fuse the additional entity information to improve subject span's representation. Furthermore, we packed each subject span and all its levitated marker of object spans to model the interrelation between same subject span pairs. And the main limitation is that EPMEI is a pipeline model, so we cannot get the final triplet in one step, but need to go through multiple consecutive steps. Thank you for your attention. That's all.
And thanks to the speaker. Now we have shorter talks, I'm told. And we start with CPAC, I guess. Packed resources for general Chinese embeddings. And we have Xiaoxi Li.
Okay,
but we have an author in the room too.
Good afternoon, everyone. I'm here as a proxy presenter for my peer's work. I'm Xiaoxi Li from Renmin University of China, and I will present this work, CPAC, Pack the Resources for General Chinese Embeddings. And this work is done by Beijing Academic of AI, also known as BAAI, at Renmin University of China, and Hugging Face, and USTC, and the University of Montreal. Well, text embedding is a long-standing task in natural language processing and information retrieval. By representing text with latent semantic vectors, text embedding can support various applications such as the web search, question answering, and the retrieval-augmented language modeling. The wide variety of application scenarios calls for a single unified embedding model that can handle all kinds of usage in any application scenarios. However, there's a shortage of competitive models for general Chinese embedding. What's worse, the development of general Chinese embedding is severe constrained in many aspects. There are neither well-prepared training resources nor suitable benchmarks to evaluate the generality. And then the CPAC. To address the above challenges, we present a package of resources called CPAC, which consists of the following 4 resources. The CMTab, a Chinese massive text embedding benchmark, and CMTP, massive text pairs for training the embedding models, and the flag embedding, the training recipes, including pre-training and fine-tuning for the embedding model. And finally, the BJE, which is a well-known text embedding model, a family of well-trained models for universal text embedding. And we will discuss these 4 resources in detail in turn. And first, the M2.5, a benchmark for the comprehensive evaluation of the generality of Chinese embeddings. It contains a total of 35 public datasets related to the evaluation of Chinese text embeddings. There are 3 groups of evaluation tasks, including retrieval, ranking, STS, classification, pair classification, and clustering, which is shown in this figure, and which cover the main interesting aspects of Chinese embeddings, Chinese text embeddings. And then the CMTP dataset. We curate the largest dataset, CMTP, for training the general Chinese embedding. To ensure the generality of the text embedding, the paired text needs to be both large-scale and diversified. Therefore, the CMTP is collected from 2 resources, of labeled and unlabeled data. The majority of the data is based on the creation of massive unlabeled data, also known as the CMTP unlabeled, which consists of 100 million data. It is constructed from the web data in the following forms. Then, meanwhile, a small proportion is from the comprehensive integration of high-quality labeled data, also known as CMTP labeled, which consists of about 1 million data pairs. And then the training recipes, the flag embedding. The training recipe of BJE is completely released to the public along with CPAC. There are 3 main components, including the pre-training with plain text and contrastive learning with unlabeled data and multitask learning with labeled data. And finally, the model, the BJE model. In our work, we provide a comprehensive class of well-trained embedding models for the community. There are 3 available skills, including large, base, and small. The large scale model achieves the highest general representation performance, leading the current public available models by a considerable margin, where the result is shown in this table. And the performance of model in English of our English models on M2.5, we use the same recipe as the Chinese models. We also train a set of English text embedding models, including the BJE EN, achieved the SOTA performance on the English M2.5 benchmark across its 56 datasets. And the BJE M3, it supports 100 languages and 3 retrieval modes, including dense, sparse, and multivectors. And third, the BJE ranker. It's a higher performance than the embedding model. It can use to rank the top K results of the embedding model. That's all for this work. Thanks for listening.
Yeah, thank you, and thank you to Yixiao for being a proxy presenter.